Good morning. Today we're going to talk about the proof of Pythagoras theorem. There are many ways to prove the famous Pythagoras theorem. Here we're going to introduce to you some famous ones. Pythagoras theorem is named after the Greek philosopher and mathematician Pythagoras. In a right-angled triangle, the longest side is always the side opposite the right angle, and that is called the hypotenuse. Pythagoras' theorem states that in a right-angled triangle, the length of one of the shorter sides squared plus the length of the other shorter side squared equals the length of the hypotenuse squared. Pythagoras demonstrated the proof by rearrangement. Take four identical right-angled triangles with sides A, B, and C. Arrange them so that their hypotenuse, C, forms a square of which the area is C squared. Then rearrange these triangles to form two other squares of which areas are A squared and B squared, as shown in the figure. The total area of these figures are the same and the area of the four triangles doesn't change. So the empty space formed in figure 1 equals empty space formed in figure 2. Here, C squared is equal to A squared and B squared. Another famous proof for Pythagoras' theorem is by using algebra. In triangle ABC, angle C is the right angle. Let CD perpendicular to AB and point D lying on AB. Now let's look into triangle ACD and triangle ABC. Angle CAD in triangle ACD is equal to angle BAC in triangle ABC. Angle ADC is equal to angle ACB as right angles, and therefore triangle ACD is similar to triangle ABC. Now, if we look into triangles ABC and triangle CBD, angles ABC is equal to angle CBD, and ACB and angle CDB are right angles, and therefore triangle ACD, triangle ABC, and triangle CBD are similar triangles. Hereby, AC to AB is equal to AD to AC. Here we get AC squared equals AB multiplied by AD. On the other hand, CB to AB is equal to BD to BC. We get BC squared equals AB multiplied by BD. Now we add the two equations together and rearrange the terms. Finally, we get AC squared plus BC squared equals AB squared. The ancient Chinese mathematician Chpt suggested a proof of Pythagoras' theorem also. Take four identical right-angled triangles with hypotenuse C and two legs A and B. Arrange them to form a square as shown in the figure. A, B, C, D form a big square with side C, while P, Q, R, S form a small square with the side B minus A. As shown in the figure, the total area of these four triangles equals C squared minus brackets B minus A squared. On the other hand, the total area of these four triangles can be calculated as a half AB multiplied by 4, as C squared minus brackets B minus A squared equals a half AB multiplied by 4. That gives rise to C squared equals A squared plus B squared. There have been over 100 approaches to proof of the Pythagoras theorem over the history. Now, can you come up with your own ideas to prove the Pythagoras theorem? Thank you for watching this video. If you enjoyed it, please do not forget to subscribe to our channel and give us a thumbs up. Looking forward to seeing you again soon.